Dan Kaiser is our next speaker. He is an associate professor of the Department of Soil, Water, and Climate at the University of Minnesota. Dan earned his master's and PhD degrees from Iowa State. His primary areas of work include fertilizer guidelines for commodity crops, nutrient cycling, and development and use of precision ag technologies in research and crop production. Dan?
All right, thanks, Tom. After the questions, I'm glad I'm not talking about potassium today. So a lot of questions out there, but what I'm going to talk about is some of the research I have on, on management of sulfur in corn and soybean production. Kind of just thinking back, this will be my 17th growing season here in Minnesota working on sulfur research, and some of the initial work we were doing was looking at more just establishing some of the initial guidelines for our non-sandy soils, and it was kind of nice at that point in time starting. We were getting some really nice responses to sulfur and some kind of nice things to show growers when you go to a meeting, stuff that's positive and something that they can do to greatly increase productivity. But one of the things that really stuck when I started working on some of this initial research was trying to get a handle on what was going on in the soils themselves. So kind of figuring out a little bit about particularly some of the differences in the fertilizer sources that are out there, getting a handle on how quickly they're becoming available, because that's one of the key pieces I've really talked with a lot of growers and consultants about it, is that when we start talking about sources, and I'll talk about the options that are available, that they're not the same when it comes to availability. And that's very important, particularly with a lot of our soils. As cold as our soils can be, there are some significant issues that need to be considered when choosing the right source. So a lot of what I've been looking at has been that source aspect, how it becomes available, then how long it lasts. That's my newer research right now, is to try to get a general handle on if I apply sulfur, since we know sulfate is a form that's taken up by crops, it's an anion, it's leachable, that is it leachable enough that we're concerned about it not carrying over from one year to the next. So that's been a primary component of what I've been looking at, is just how long lived some of these applications are. The sources of sulfur that we're seeing in fertilizer, I mean, outside of manure, I'll talk about manure here at the end. This is the only comment I'll make on manure. Here's in the slide, but typically fertilizers contain sulfate. We see a large amount of ammonium sulfate sold in Minnesota, which I think is a positive when it comes to availability, because again, sulfate is the form that's taken up. Elemental sulfur, I'm going to talk about this. I mean, that's the main thing with elemental sulfur, is that the products differ greatly in terms of their availability. And I'll talk about some of the components on that, because it's some things to think about when it comes to management. Depending on what source you're applying, it might take a different style of management in terms of how you handle these materials. Because the product, when it comes to elemental sulfur, it needs to be oxidized. It isn't mineralized. Organic matter mineralizes sulfur. We would say, rough rule of thumb, if you're looking at the amount that you mineralize annually, is about 3 to 5 pounds of sulfur mineralized per percent organic matter in the top 6 inches per acre per year. So a lot of the recommendations, when I started to do the initial basis for the recommendations, I went with organic matter, because I'm not going to talk anything about sulfur soil tests. They just do not work very well, particularly outside of sands, because of some of the processes by which sulfur transforms in the soil. That's one of the things I'm interested in right now, because it's interesting where it seems like things start to disappear. I've seen my soil tests actually higher the last few years in these dry years versus wetter years when they tend to drop, and they just aren't very predictive of where a response is going to occur. And the organic matter isn't the be-all, end-all. We know that crop residue, particularly corn, is going to immobilize sulfur when it decomposes, so that's why my recommendations for continuous corn are different from corn following soybeans. We also know that drainage is a factor to wet soils. We tend to see where we see some of these little processes here in the soil tend to change depending on, again, drainage and how dry the soils are. So it's complicated. I thought I had it all figured out about 7-8 years ago. Then we started getting some more data from some areas of the state showing deficiencies in areas that I didn't think we should be seeing them. So that's why it kind of roped me back in. And here I am 17 years later, still working on sulfur. If you do have livestock manure, the number I typically would give to a grower for availability is about 65%. Now realize this is an average. If you have pit manures, I think that number is far less. And I think that's just because you end up with a lot of reduced sulfur in the hydrogen sulfide form, which isn't overly available. If you have pack manures or anything that's got a high level of organic material, you're probably going to have more availability. And it just, some of these processes by which, because sulfate can be, we talk about denitrification and the reduction of nitrate. The same thing could happen with sulfate. It typically happens, I mean, theoretically, after nitrate is consumed by bacteria, they'll start working on sulfate for looking for oxygen, but it's not as clear cut as that. And that's one of the things that I've been trying to prove in some of our soils, that some of these processes occur annually, even with nitrate present, that we see some of that reduction occurring as well. That makes it more of a complicated process when we look at availability from one year to the next. So a couple terms I'm using here, potassium sulfate, I use that a lot in my research. It's not that I'm endorsing or think that everybody should use potassium sulfate. If you look at potassium sulfate, gypsum, which is calcium sulfate, or ammonium sulfate, they're all pretty much the same. I mean, when it comes to availability, I mean, gypsum sometimes can have some differences in solubility. I just generally use them interchangeably. It just, for the bulk of the studies I'm going to show you, potassium sulfate works out better, just based on what I'm doing. And so that's why we tend to use it. It's not something that's widely available. It's got a higher cost per pound than some of the others, but it just works better for some of the studies. Elemental sulfur, you'll see something that's called KMST. MST stands for micronized sulfur technology. This is a Sulveris Limited who's been marketing some of this through Nutrien. What this is, and I'll talk about this with elemental sulfur, is like lime, particle size of the material matters significantly in terms of the availability. So the micronized products, they have essentially elemental sulfur around a 10 micron size. In most of this material, when you look at the majority of the other materials, it's somewhere between 40 and 100. And again, that affects the availability, but I'll talk about that. So MST is just micronized sulfur technology. I'm using a potash version. That's why I use potassium sulfate for the direct comparison. And it does have some differences. The bulk of what's on the market right now for this MST product is MAP based. So MAP MST, if you've seen this. Essentially, I've tested against it. I'm not going to show any of that data. I mean, really, with a lot of these products, particularly like the micro essentials, any of those that have elemental sulfur finely ground up in them, really the availability depends a lot on the fertilizer matrices that it's mixed within. And we know that phosphate sources, I've seen it in dry years where they don't dissolve as quickly. So that can impact availability. But, you know, potassium, that's why I typically use it, because it dissolves readily and it affects the availability. Tiger 90, it's elemental sulfur mixed with bentonite. I'll talk about this. I mean, those two together, when it comes to incorporation, don't really work so well, and I'll talk why that is, just because of the material. And then ammonium thiosulfate, I'll talk a little bit about that at the end. You know, that material works very well for a liquid source, but it is somewhat different, and I'll give you a general handle on that. But I wanted to cover that first because I get questions on the MST a lot. And I've just said using it based on preference because it's a material that's 100% elemental sulfur. With micro essentials, you're getting half your sulfur as elemental and half as AMS. So if you're getting a response, it becomes hard for me to then use a product like that to discern between the two responses, when in many cases I don't need a whole lot of sulfur to get maximum yield within the first or the single year that I'm looking at within studies. So elemental sulfur, what happens when it's oxidized? This is just a general representation. You add oxygen, water, microbial activity, it forms acidity and sulfate. And that's one of the things that it will acidify the soil as you apply it. The main thing about it, although there is information out there from at least one source I know of talking about how growers should be using it to acidify their high pH soils, it's not that simple. It does acidify, but with many of our soils, it's not a good way to look at correcting iron chlorosis, because we have much more alkalinity with depth that you could spend hundreds of thousands of dollars to try to fix this problem with, and it's never really gonna affect that. Plus, with elemental sulfur, I mean, really looking at that, it's a microbial activity that dictates this, is that our cold weather tends to slow that process significantly. And I get a lot of questions when it comes to elemental sulfur about fall application. Does that set us up better? And really, I don't think that's the case looking at all my data. I mean, looking at it in terms of the cold weather conditions, the placement and incorporation really are the two key factors that affect things more than timing. And a lot of that just has to deal with the fact that we're cold, and those microbes don't really like to work. They like to work when the soil's around 95 degrees Fahrenheit. which is something that's relatively warmer than we're going to hit, or that in most times during the year. So you're not going to get a lot of availability from it, and it's not going to help you getting more availability in the spring from elemental applying it in the fall, just because again, its soils are just too cold. You're not going to get much availability. So are all products are they equal? I mean, concentration is important. I'm going to talk about this. I think that's one of the key things when you're talking about a product like Tiger 90, which is 90% elemental sulfur. It takes about 6 times less the amount of material to give you the same rate of sulfur as it would be like a product like Micro Essentials or these MST products, which are roughly around 15% total sulfur. And that's one of the things to think about. One of the things that's always brought up is when you start talking about the amount of material applied per acre, being that you've got a more concentrated product, you're getting fewer of these little, this is Tiger 90, which has, they call pastilles. So they look like little kind of half spheres that it's 10% bentonite, 90% elemental sulfur. So the way this product is supposed to work is the bentonite absorbs water. When it absorbs water, it swells. And as it swells, it's supposed to break apart those individual small elemental sulfur particles. So that's a dispersion factor. And that's one of the things, and I'll talk about this, if you bury it, elemental sulfur is not water soluble. It will not dissolve in water. So what ends up happening, essentially, since it won't dissolve in water, is you just end up with one big clump of bentonite and elemental sulfur in the soil if you bury it, where it will only very slowly oxidize. So I'll talk about kind of my strategies for it and how to get around that at the end, because there are some things to think about and some things that are recommended with it. It will work, but there's some certain things you have to think about. These are just the micron sizes. So you look at Tiger 90, the individual particles are between 30 and 130 microns. Their median's estimated at 60. Micro Essentials reported at 25 to 100. Their median's 56. Then the MST, it ranges from 1 to 15, and they average around 15 microns. So again, like lime, the smaller the particle, the quicker the reaction. So with cogranulated products, I mentioned this before, really the availability, I think, depends more on the matrix and how it dissolves and releases. Some things are going to be more like the potash is going to be more readily dissolvable than the MAP or the DAP. But in effect, if we get enough moisture, that shouldn't be a problem. I said where I've only run into problems with this has been in dry years, where it seems like we're getting poor availability, particularly maybe of the MAP, but also not seeing as much dissolving of the material where that elemental sulfur is released to a point where it's actually being reacted on by the bacteria. One of the key things I've had a lot of questions on is elemental sulfur. If we do have availability issue, is it a long-term thing where if we applied enough over time, will we get enough available where we can build enough in the soil? And I will say building of sulfate, because I think it does happen. I know I've got a lot of data. If we look at the top 2 feet of soil, where I can generally see an application 2 years post-application somewhere in the soil test. Now, the soil test isn't the greatest indicator, but I can detect it. So I know it's there. I know it carries over. So that's been one of the questions. And if we know where I look at here, my critical deficiency period in Minnesota really is that early stage. It's in May. And through about V10, and the field sites where I have the most issues are the sites that will remain sulfur deficient and striped till about V10. There's many soils out there, and I think some of our hybrid genetics we have right now grow too fast where we can't extract enough sulfate, where they will stripe early on. The thing is, though, if we can get available sulfur, and I've got data on this by about V6, the plants will recover. So we don't necessarily need to be worried too much about some faint striping that we could see in the plants. It's really if it progresses beyond this point, and V10 is really a critical period on that. Many of my sites where I have pretty severe deficiencies and some significant yield increases from the sulfur, I still can see the striping into V10. Some of them, like at Rosemont, some of the data I'm going to show you, the plants will recover. And that's one of the interesting things that we start to mineralize, the plants recover, but they're still striping on the lower leaves. And it's one of the things, the upper leaves seem to be fine, but the lower leaves can still show some deficiencies. And I'll see maybe 5 to 10 bushel yield difference at that site versus Waseca, where it'll just look like absolute hell for most of the season, and I'll get about 60 to 80 bushel difference in some of those plots. And it affects the nitrogen utilization with that. So it's really about that critical nutrient efficiency period, and that's where it worries me with some of these elemental sulfur sources. If we don't get availability at that point, we've got a problem with that. So that's one of the things, even with fall applications, where I worry about it, and it's just a question of whether or not some of these products will release sulfate late enough where we increase the soil sulfate supply, where it'll start to carry over from one year to the next. So that's really what I've been looking at right now with much of my data, is just to see if that carryover effect actually occurs. So this is just a representation I put together looking at a product like Tiger 90. If you look at these dots being individual soil particles, the space between be the pore space. You see a product like Tiger 90 where these are representing the individual elemental sulfur particles, where we have a lot of particles, where they're packed together. Essentially, they act as one large particle. So in effect, it slows down the oxidation. We look at a soil like a sand, something that has more porosity, a bigger pore space, where the particles can spread out a little bit more, you're going to get better availability. And that's what a lot of my data shows. Sands, looking at the sources really haven't mattered as much. I can get away with about whatever I want to apply. Silt loams, initially when we go into applications, I see problems, but over time the numbers look better. And then clays, looking at the availability, some of the yield data I've got shows about 25 to 50% availability of elemental sulfur. So you're looking at, double to 4 times as much material to get the same effect as you would with the sulfate. So while it can be cheaper, that's one of the things to consider, is that it might take more to get an effect. And that's one of the reasons too, if you are looking at band applications like strip till, I would not use an elemental sulfur source unless it's one of these co-granulated sources. Tiger 90 is not a good product to use if you're banding just because of burying that material. I would just make sure that you keep, and again, I'll talk about this in terms of my strategy and how I would deal with this. Now, if you compare this to a product like the Micro Essentials or the MST, where you've got, it said, about 6 times less material per unit granule, you look at it, you're gonna have much more space, even in these tighter soils, to get this product oxidized. And again, I'll show you a lot of this data. The yield data shows this. The availability, while it isn't necessarily immediate, I've got a lot of numbers in that. Just looking at the yield data with Micro Essentials, MST, I see pretty similar effects to the AMS. So if I'm doing immediate incorporation in the fall, that's one of the things I would consider, is something like a product like this instead of Tiger 90, because I think you're going to get a better availability and not take as much material to get the same availability of that. But you just visualize it again, because if these material there, they need space. They need space, and they need space for the bacteria to react in these particles individually instead of acting on them like one massive block that's buried in the soil. So I've had a number of studies going on. Again, we started a lot of work with Minnesota Soybean Research and Promotion Council. They did a lot of my funding of my early research. Minnesota Corn, and then AFREC has been a lot of the late funding. And this is looking at a study. I started this, actually, this would be the 6th year of the study, so it'd be 6 years ago, where we started initially looking at field locations where I was applying 3 rates, 10, 20, and 30, or 5, 10, and 20 pounds of sulfur as 3 sources. The control is no sulfur. So this is no sulfur versus potassium sulfate, potassium MST, and Tiger 90. These are the 4 locations that we tested: Becker, Morris, Rosemont, and Waseca. Becker is the only irrigated site, irrigated sand, coarse textured soil. So that contrast with Rosemont, silt loam, Morris, and Waseca are both clay loams. Actually, Morris is actually a silt loam, that soil, but it's a pretty tight, heavy clay, wet soil. So the idea here essentially on these studies was to look at those rates, the sources, go 4 years, continuous corn, and then at the 5th year, I was going to cut the plots in half. So essentially, so I could look at what happened over 4 years with annual applications where the same rate and source were applied annually, then to see the longevity of these products, to see how long it takes us to run out of gas with these products. How long does it take for the sulfate to get to a point where we've run out, where it gets to where the treatments behave much like the control. So this is the initial, again, the 4 of the build phase on this. If you look at the sites, Becker sources didn't matter, Morris sources didn't matter. In Morris, if you look at rates, really no effect in sulfur of that. There just was too much, a high organic matter. We didn't see a problem with that. I see some soils at that station where we do see some issues, but this one wasn't one in particular. And Becker, if you look at it, sources, no effect, but rate. So it didn't really matter what I did, but rate was important. So initially, about 10 pounds of sulfur annually is about what I needed for continuous corn to maximize yield at that location. Rosemont and Waseca sources did matter. Rosemont initially, if you looked at the Tiger 90, didn't do as well. For the first 2 years of the study, there was an interaction there. On average, it yielded about the same as the MST and the sulfate. Both locations, the MST and the sulfate did the same. So again, we're getting similar availabilities for that. The only site where the Tiger 90 was less was Waseca. And if you look at it, I mean, it was 120 average for the control, about 175 for the sulfate and the MST, and about a 150 for the Tiger 90. So again, we're looking at about half the yield with the same rate of Tiger 90 versus the other products. Rate-wise, 20 pounds, Rosemont slightly lower organic matter. It's what I generally recommend, slightly more for if you get 3% or less of 20 pounds. This fits with our recommendations. And then Waseca, really the 10 pounds we're looking at over time was what the optimal rate was. So again, this was stage one of this. This was stage one. Last year we started stage two, which was looking at the carryover effect. And I will show you that here in a moment. The other thing I was trying to look at was trying to get a handle on what was happening during the growing season. So try and get a handle on what the plant was seeing from these particular sources. The best way that I found to do this was with these ion probes, which we have 4 of them buried in the soil. It's kind of hard to see. There's a little orange in there, where we replace them about every 2 to 3 weeks in the same slot. And these probes mimic a root. They measure a flux, which is essentially an absorption of a nutrient per unit area per unit time. So this is essentially simulating what the root may potentially find in the soil over time from the individual sulfur sources. So I can track with this when the sulfate, if it is releasing from these elemental sulfur sources, when is it becoming available for that. So we did this for 4 years. We only did this in the 10-pound rates though. So I was only looking at kind of what I would recommend for annual applications for the majority of these sites. I didn't want to do too much, but I didn't want to do too little to make sure we could see some availability of the product. So this is just from 2022. So I'm going to explain this graph a little bit. So what I'm looking at essentially in this graph again is the flux. So essentially is the amount absorbed per unit area per unit time. What this is normalized by the control. And I did this so I could look at what was coming from the fertilizer versus what was coming from the soil. If you look at these graphs, if they're flat, that indicates essentially that we are getting absorbed at that particular time periods was all coming from mineralized organic matter. So essentially everything is similar to the control. So I'm really looking at points in time where we see these graphs increasing to look at availability. I'm going to see if my my pointers are in here. So you can kind of look at initial availability, that obviously that we tended to get more initial availability from the sulfate. And we know that because sulfate is readily available when we apply it. We're getting more initial availability from that particular product. So you'll see that in a number of the sites where this gray, which is the sulfate, is slightly higher initially than, I mean, some of these actually the MST is pretty close. In most cases, if we looked at the MST, a lot of times we were seeing it took about 2 to maybe 4 weeks for that MST to start to oxidize enough we were redetecting it. But overall, looking at that critical early time period, the MST was showing us pretty similar results. The Tiger 90, which is the yellows, you look at Becker here, substantially greater availability over time with that Tiger 90. It actually worked better almost in the sands and some of these other sources. At Rosemont, you look at Waseca, I mean, you look at Morris, I mean, honestly, I couldn't really detect anything there. Now, I don't know if some of this issue with this Tiger 90 availability, because again, the yield data would show about 50% availability to 100% depending on the site, that if it just deals with the fact that, again, we have less material per unit area. So essentially, it could just be with the lower amount of these little pastilles or granules or whatever you would call them, that maybe they weren't intercepting where those probes were. The data wise, it would say though about, again, the yield data would say there's something there, but it's still, depending on the site, not quite as much as the other sources. The interesting thing there, when we start talking about a lot of these elemental sources, a lot of people talk about extended season variability. Look at those red areas there, and everything's flat beyond that. I would say roughly around August. I can't detect any of that fertilizer. I mean, everything we're absorbing on these probes is coming from mineralized organic matter at that point in time. So if it is oxidizing that late in the stage plant's likely not probably utilizing it, or it's deeper in the profile. I don't know. But I mean, I don't really think that, I mean, even given time that some of these materials at that late uptake, I mean, most of it's coming from organic matter mineralization and not necessarily needed by the fertilizer at those point in time, just based on what we're absorbing. It's just too dry. I mean, a lot of these years at that point where the moisture is too low, where I don't think we get very good oxidation because, you know, it's a little bit slower because of how dry it is. And that's what typically we saw, is a lot lower availability towards the end of the growing season. So again, the new part of this was looking at the carryover effect. So what we did is that each of these plots individually at those 4 sites, we actually discontinued 2 of them because Becker and Morris didn't show any effect of the sources, so I didn't really feel a need to carry those over. But the other 2 sites, we cut the plots in half. I stopped applying on half the plot, and then we just continued the annual applications the other half. So this is year 1. This is the average, or this is looking at Rosemont and Waseca. I saw pretty similar results at both of them. And this is averaged over the 3 sulfur rates. The 5-pound rate, looking at the data, that's probably a bare minimum rate annual just based on the numbers. There wasn't any significant differences on there. That's why I'm not showing it. But if you looked at the data, I mean, the yield was slightly higher than the control, but not much. So the 10s and the 20s, we're seeing some carryover. If you looked at this is annual, so this would be essentially where we continued application in the gold, and then the maroon bars next to it would be the residual. So essentially that's where we cut the application off. That in general, the MST, we're seeing enough carryover where it seems like we're still getting about the same yield from the residual, no really advantage from the annual. The sulfate, again, it kind of depended on the rate, but on average, we're still seeing carryover substantially from those 4-year applications in year 1 of the carryover effect. The interesting here is Tiger 90. If you look at the annual and residual, seeing a similar effect. And this actually makes me think, or makes me wonder, is that kind of what I was thinking before, is what I showed before, is that long-term approach, is that we're not getting availability initially, that, maybe what we are getting available for that 50% availability is coming from previous year's applications with that. So we'll kind of track this, but this has been one of the things I've been wondering for quite a while with that. And, just from a management standpoint, I have, and a lot of it is with Tiger 90 is managing it, is that we may be undercutting what's actually needed on some of these sites with that product if it's not becoming available. So again, we'll track we'll see what happens with rate, but right now 5 pounds, we know that many continuous corn situations, 2 gallons of ammonium thiosulfate is typically been sufficient, which applies about 6 pounds of sulfur for an annual application. But if you're looking at any benefits for soybean, and that's another thing I'm looking at right now, is tracking those carryover benefits, that 5 pounds probably not going to be enough. And that's what we've generally seen, 15, 20 pounds. If you're in a corn soybean rotation, it's why I recommend that typically for corn, just because of that carryover effect of what you can see. So does it carry over? I think maybe depending on source, but the main thing here is the fact that sulfate doesn't just immediately leach out. So I'm not worried about, even with years where we've had rainfall, it seems like the sulfate is carrying over. It's at least in the top 2 feet, somewhere in that profile, and we can measure that again about 2 years after application. So I'm not as concerned about that leaching too quickly, that a fall application or other situations where we're worried about leaching it, where it becomes much of a problem. I have been looking at ammonium thiosulfate. I just highlighted in red the main effects here that you're really to be concerned about. This was a study we're looking at continuous corn, looking at low organic matter versus high, less than 4, greater than 4. Looking at different sulfur strategies. So AMS, ammonium sulfate broadcast after planting. This is ammonium sulfate broadcast with flat fans. So be just mixing ATS in with a pre-emerge, would be simulating that, versus ammonium thiosulfate banded to 1 inch to the side of the row with the planter. So this would be the typical what Jeff Vetch has talked about a fair amount, looking at that planter banded treatment on the soil surface to the side of the row. The main thing about this, really the sources, you'll see a little effect, but overall it's negligible in terms of those different strategies. Really it was a rate effect here. So that's one of the things I've seen with sulfur. As long as it's available sulfur, you've got an available form. It really doesn't matter what you do. You've got a lot of options. And I don't think the banding is any more efficient. I think it's just the fact that with banding, we put lower rates on it, probably more towards what we need sufficiently from 1 year to the next with that. And really, in effect, broadcast band, it really doesn't matter. Again, as long as it's there, really it's the rate. So again, these 5 pound rates really about where we maximize yield. So 2 gallons of ammonium thiosulfate. I have had some struggles. I do have concerns with continuous corn with ATS broadcast. And a lot of that has to do with residue interception. So if you have continuous corn, I'm concerned essentially about tying up some of that sulfur if you're applying it directly on the residue. So that's one of the things I probably would go away from that if that was, corn following soybean, you could probably easily put ATS in with your pre-emerge. But corn following corn, it's one of the things I would watch out for. I think you're better off probably banding that at some point, whether it's with the side dress with a planter band or ammonium sulfate. It just ATS, I don't think it works quite as well. And that's one of the things to watch out with rate. But again, looking at this, a lot of flexibility. One thing I will say about thiosulfate, now, some of you may have heard me talk about this in the past. If you look at it, this is thiosulfate, the ion. So what you're going to, this is sulfate, this is thiosol versus sulfate. So you look at the sulfate ion, 4 oxygens, 1 sulfur, the thiosulfate, 2 sulfurs, 3 oxygens. I've talked about thiosulfate being both an elemental and a sulfate form in the past. It's not exactly true because what happens with thiosulfate is actually 2 of these atoms will join together and they form a compound called tetrathionate. I mean, it's not anything you need to know outside of the fact that it's highly available. I mean, it'll dissociate quickly. Thiosulfate, very available. Even if you've got about roughly what should be half of your sulfur in the elemental form, the availability is pretty quick with that. So with thiosulfate, ammonium sulfate, I see similar results with that. So you might hear some people talk about that. Again, this chemistry isn't anything you necessarily need to know the fact that it's readily available. I don't treat this the same as I would treat elemental sulfur dry forms, just because, again, you've got atoms here versus a big clump of material, which tends to slow the availability. So what would I do with elemental sulfur? Since it does have to be broken down into smaller particles before it can be oxidized, I mean, really, you have to leave it on the surface. And that's what Tigersol recommends with it. It's about 2 weeks on the surface before incorporation. And that's assuming you get rainfall to swell the bentonite, because then hopefully once the shovel of your tillage goes through, it'll break that pastille apart to effectively disperse, or even just raindrop impact will disperse that particle enough where you're not going to get a big clump of material buried within a pore under your soil. So that's what I would generally recommend for that. I'll show you some data. I've had better luck with just fall application without incorporation. The issue with that is, though, that's not really my BMP for other fertilizer sources. I mean, really with phosphorus, it's really, in potassium, it's good to incorporate them. So that's one of the things, and that's why I don't recommend, I wouldn't recommend Tiger 90 with strip till, because I just don't think you're going to get anything available after you bury it in the soil. So it's really, I mean, it's about leaving it enough time to disperse in the way it's supposed to disperse, and it can't do that when it's under the water. And then again, the particle size is an issue. I don't think it's as big of an issue, although, you know, some of these MST, at least we've seen the availability is pretty consistent with sulfate. I have looked at fall versus spring. This was an average between 2 sites we had back in 2022 at Rosemont and Waseca. So we're looking at fall spring application, AMS, Tiger 90, 50-50, a Tiger 90 only. Then we had a product called Sulfur Max, which is gypsum with elemental sulfur. And this is looking at it with and without incorporation. And even the fall application of the Tiger 90, we didn't incorporate. And if you looked at the data, really fall versus spring, you know, looking at it, not much. I mean, actually, I was looking at get favored fall, at least in these particular sites with the elemental sulfur sources with it. But again, I think you have to couple the fact that we also didn't have incorporation in many of these products. So I think that's the key on this with it. If you're looking at availability on these, that really time is a factor, but incorporation is the bigger factor when it comes to availability of many of these elemental products. So that's what I just suggest with that. If you're thinking about that, you have to think about this differently, and you can't just go through with the tillage right after application to bury these products becomes a problem. I have looked at it as well in alfalfa. I see a lot of the same things. This is looking at potassium sulfate, potassium MST. This is just looking at Rosemont. We've had some really sizable yield increases where we've been looking at 1,000 to 1,500 dry pounds per cut with sulfur, MST in it, and potassium sulfate been about the same yield with that. You're looking at rate-wise, look at annual rates, we're putting it on after first cut about 20 pounds. That's what I would look at doing. Net return has been high. I mean, you look at it, 20 pounds of sulfur, about $235 to the acre is what I figured for just those 20-pound annual application rates. So it's pretty significant. I'm picking up about 2% protein on this site too on average with the addition of the sulfur. So it's big. I mean, over 2 years, 300, I mean, it's huge. I'm about done. So, and this actually was looking at where we actually put down, this is 120 pounds of sulfur put down at its initial application with no further applications in alfalfa. The big thing I want to show you here is with Tiger 90. I did that with Tiger 90. We're still seeing it lag. And that's, again, with incorporation. Now, if you have alfalfa and you are putting it on the surface without incorporation, you'll probably be fine with that. But, you know, looking at the other thing I was looking at here is whether or not it, you know, a 3-year or 4-year removal rate, if it leached out substantially from that alfalfa, over time, and we're still seeing a lot of carryover with that. So it isn't leaching as quickly as you would expect with it. So again, looking at that as less concerned, but again, seeing some of the same impacts with Tiger 90. I think it all just boils down to, again, incorporation. If we would have included Tiger 90 as an annual application on the surface with this, I doubt we'd have seen much difference. And that just because with alfalfa, since you're not incorporating, that's the best case scenario of getting some moisture to get that material dissolved and oxidized. So if you are interested, that QR code will go to that. We finished that study this year. It's an Afric study. It'll go to the main launching page for that, and you can look at any of the data off of that. I don't have the fourth year report done, but it's due year 3. So wrapping up, a couple other things. MAP and DAP, I'm less concerned with high rates of those about being real specific about high rates are really just down to the pound, because MAP and DAP contains 1 to 3% total sulfur, which is available as, and it's not included in your fertilizer analysis. That's one of the things to think about. You're getting a few pounds there still that is available. So that's why, 20 versus 30 pounds, if you're getting 5 pounds with your MAP or DAP, I mean, getting too crazy in terms of being real prescriptive on rates, you're still seeing some sulfur applied. We talked about the availability, ATS, good option. I think it's at the bottom, it's a good option. There's a lot of options here. So with that, I can't remember where this QR code goes to. I think it kind of clicked off there. I think it goes to our main website, but we'll take a few questions here. So are sulfur rates and nitrogen rates needed in certain ratio for each other? There is a certain ratio of N to S when it comes to breakdown of residue. I haven't seen anything where a certain ratio is necessarily needed though, because in many cases I can have a wide range in nitrogen rates and still be applying only about 10 pounds of sulfur and get maximized yield. I've looked at the interaction between the two. And mainly the interaction, what I was seeing is that obviously, since nitrogen is needed in higher quantity, that if you underapply N, you get poor utilization of sulfur. But it is, looking at the data we have at Waseca for the long-term study, is one thing I do see is in our plots that are sulfur deficient, they'll be sulfur deficient early. Then mid to late season, it'll all be nitrogen deficiency. So I know there's a relationship between the two. I haven't just identified whether a specific ratio is needed on those sites. It just seems like we just get poor utilization as a general, and that might be because of poor root growth. We're just not exploring enough of the soil to take up the nitrogen. The other thing we've seen with some of these plots that have been delayed in emergence at a few of these sites is we've got hit harder with corn rootworm. They seem to like that delayed emergence or that delayed silk emergence, and those control plots really get hammered in some of these sites. We try to use best practices for controlling them, but it isn't always perfect with it. So there's been a few years where you get really large yield responses, and it's a combination of the nitrogen and the rootworms really hammering the control plots with that. So in Waseca, the Tiger 90 yield response is very low compared to other plots. Is that because of the tighter pore space? I think yes. I think that's part of it. I just don't think if we're bearing this, we're treating these all the same, so I'm not using optimal practices at the site. I will put that out there that it wouldn't be how I would probably normally do that, but I need to keep it all the same. So yes, I think that's a lot of it. Tighter pore space, the product's getting buried, it's just not oxidizing, and I don't think it's ever really dispersing all that well over time. We're getting some, but we're probably still only getting about 50% availability. So again, most of the particles are clumping together. What commercial products are using MST? MAP MST Nutrient sells that. So that's the only product out there. They aren't marketing the potash product to what I know of. I wish they would. I think it'd be a good product to do, but the majority of what they're focused on has been MAP MST. Is it safe to use sulfur as a nitrogen stabilizer? Ammonium thiosulfate will have an inhibition effect on urease activity. It's not as good as agrotane, so it might give you a few days, and a lot of that's because of the acidity it produces. The more acidity you produce, it will somewhat stabilize urea forms of nitrogen because the acidity forms ammonium. So there is some data out there, but again, you need at least, I think, 9% of the total mix as ATS, and it's just not going to give you the hold. So if you're looking at good hold, you need to look at a product like agrotane. So we got time for a few more, or you want one more question? Given the current lower temperature, lower moisture, is dry EMS or liquid ATS both the preferred source? I mean, both those two should dissolve pretty readily. That's one of the things. It doesn't take a lot of moisture to dissolve those products. I don't know if it really matters because we've had some dry years with those. So if you have micro essentials of the MST, I think looking at the data we've got, you should still see enough availability of that even with the lower moistures. It really kind of matters, I think, more in the spring just to start dissolving that product. And there's generally been enough. I mean, we tend to see it lag at the end of the season, but again, it doesn't seem like we need the fertilizer at the end of the season as much. So I don't really worry about it as much. I'd worry more about Tiger 90, but still looking at that, I don't think we've seen too much difference in just based on the data I've got with it. So I don't know if I'd change it too much. It's just more or less what you're trying to do and when you need available S. That's really what you need to match with it. So if anybody has any questions, email me. Further ones, just feel free or give me a call. My contact information is there. And then we should start releasing a few more things over crop news on some of this stuff too. So that's a good plug for Minnesota Crop News. If you aren't subscribed, it's a good source for some of this. So I try to update on some of these products that are going on annual. So with that, thank you.